Earth is defined by its water. Yet, despite the ocean covering the vast majority of our planet, over 80% of the seafloor has never been seen or mapped by human beings. This gap in our knowledge is stark when compared to our reach in space. This is the surface of Mars. We have higher resolution visual records of this alien world than we do of the terrain at the bottom of our own Atlantic or Pacific Oceans. The barrier is physical. While the vacuum of space is transparent to our telescopes, the ocean is a dense wall. It absorbs light, blocks radio signals, and creates a compounding weight that increases with every meter of descent. Because we cannot observe the abyss from a distance, discovery requires physical presence. To understand the seafloor, we have to build machines that can withstand the drop and sink into the void. Our exploration begins in the shallows, where the ocean hides the remnants of human history. At the end of the last ice age, rising sea levels drowned vast coastal regions, turning former human settlements into underwater archaeological sites. Sites like the Yonaguni Monument off the coast of Japan highlight the mystery of these submerged lands. These sharply angled terraces appear architectural, leading researchers to debate whether they are natural geological formations or the ruins of an ancient civilization. Further out at sea, the mysteries shift from archaeology to navigation. In 1945, the 5 torpedo bombers of Flight 19 vanished within the Bermuda Triangle, fueling decades of speculation about the region's supposed dangers. Modern science offers more grounded explanations. Sudden eruptions of methane gas from the seafloor can instantly reduce water density and sink ships, while magnetic deviations in the region can cause compasses to provide false readings. These surface anomalies are only the beginning. The environment becomes truly alien only after you descend past the reach of the sun. A few hundred meters down, the sunlight disappears. In this total darkness, the rules of survival change, and biology takes on strange, luminous forms. This is the domain of bioluminescence. Predators like the anglerfish use chemical reactions to create light, dangling glowing lures to draw unsuspecting prey toward their jaws in the freezing dark. In zones where oxygen is scarce, life has adapted through extreme biological shifts. These organisms possess slow metabolisms and enormous bodies, allowing them to thrive in conditions that would be lethal to surface-dwelling creatures. This giant squid specimen provides proof of that deep-sea scale. Growing over 10 meters long, these elusive titans were once thought to be mythical, precisely because they live at depths humans rarely reach. These creatures demonstrate that biology is remarkably plastic. In the abyss, complex life forms have specialized to exploit a habitat that was once considered entirely uninhabitable. Reaching the abyssal plain reveals the geological engines of our planet. This is a landscape shaped by immense tectonic forces and volcanic activity. Thousands of underwater volcanoes are active on the seafloor. They vent intense heat and minerals into the water, building new sections of the Earth's crust. Near these volcanoes, we find hydrothermal vents. These structures act as oases in the desert of the deep sea, supporting dense colonies of life in the freezing dark. These ecosystems function through chemosynthesis. As shown in this diagram, instead of relying on the sun, these organisms extract energy directly from the hot chemicals and minerals erupting from the vent. The observation of life thriving on volcanic gases revised our criteria for habitability. It confirmed that geothermal energy can replace the sun as the primary driver of a complex food chain. The most extreme of these environments is the Mariana Trench, a massive fracture in the crust that drops 11 kilometers toward the Earth's core. To understand that scale, consider Mount Everest. Placed at the bottom of this trench, its peak would still be submerged under 2 kilometers of water. The physics at this depth are terrifying. The weight of the water creates over 1,000 times the pressure found at the surface, enough force to implode most industrial metals instantly. Human exploration requires massive engineering. This is the Trieste, a heavily armored bathyscaphe with thick pressure shielding designed to keep its crew from being crushed. While we use rigid steel to resist the pressure, native organisms use a different strategy. They possess soft, transparent bodies that allow the external pressure to equalize internally, preventing them from being crushed. The absolute bottom of the ocean serves as a natural laboratory where resilient biology operates under the most extreme physical constraints found on the planet. Rising back up to the surface from the deep abyss reveals just how much of our own planet's immense biosphere remains hidden below. From a ship, the ocean appears as a uniform expanse of blue water. Beneath that surface, however, lies a series of stratified, autonomous biomes that function as an alien world within our own. With millions of species and massive geological features yet to be discovered, we are only beginning to understand the true scale of the abyss. While humanity looks to the stars for new worlds to explore, our own planet's greatest mysteries are still waiting in the dark depths of the ocean.